Hi, everyone, and welcome. So, have you ever looked at your PC and just wondered, where did all that speed go? Well, if that's you, you are in exactly the right place. Today, we're going to solve that mystery. We're diving into an awesome, super comprehensive guide from ian.techfocus.rs to uncover the one number that's key to unlocking the performance you already paid for. Trust me, monitoring this could be the smartest and cheapest upgrade you ever make. All right, let's get into it.
You remember it, right? That feeling when your machine was brand new. It was blazing fast, so responsive, just powerful. But then, slowly, over time, that power just seems to fade away. If your expensive PC now feels like it's stuck in mud, you're not going crazy. The big question is, what if there's a silent thief stealing your PC's power right from under your nose?
So, in this first part, we are going to unmask this invisible thief. We're talking about a culprit that works completely in the shadows, quietly draining your PC's performance without a single pop-up or warning sign. And here it is. The name of our thief is thermal throttling. The best way to think about it is like this. Your processor is the engine in a high-performance race car. Now, when you push that engine to its absolute limit, it gets hot, dangerously hot. So, to prevent the engine from melting, the car's computer cuts the power. Your CPU does the exact same thing. It's a really smart defense mechanism, but the price you pay for that safety is speed. Okay, check this out. This slide shows you the crime happening in real time. Look at that bottom graph. See how the temperature suddenly spikes way up into the danger zone? Now look at the top graph at that exact same moment. The CPU's clock speed, which is basically its performance, just takes a complete nosedive. That is a perfect picture of your processor slamming on the brakes to save itself from overheating. So what does this actually feel like when you're using your computer? Well, if you're a gamer, it's that moment of pure rage when your frame rate tanks from a buttery smooth 120 FPS down to a choppy 30, right when you're in the middle of a fight. If you do creative work, it's that video render that should take 10 minutes, but it's suddenly crawling along at 30. And for just everyday stuff, it's that annoying system stutter, lag, or even random reboots. Yep, that's the thief at work. Okay, so we know who the thief is now. The next step is to learn how to read the evidence it leaves behind. In this next section, we're going to become detectives and decode what all these temperature numbers are actually telling us about our PC's health. Honestly, the easiest way to wrap your head around this is to think of it like a medical chart for your processor. You know, just like a doctor checks your body temperature to see if you have a fever, we can look at these different color-coded zones to get a quick diagnosis of our CPU's health. So, these are the numbers you really need to know. In that idle zone, somewhere between 40 and 55 degrees Celsius, your PC is just happy and relaxed, browsing the web. When you're gaming or rendering a video, you're going to be in the load zone, between 70 and 85 degrees. That's totally normal and safe. But, and this is the big one, if you see your temps constantly pushing into that critical zone over 95 degrees, that's a huge red flag. Performance loss is pretty much guaranteed at that point. Now, here's a little detail that trips a lot of people up. You might see your shiny new processor hit 100 degrees for a split second and immediately panic, thinking something's broken. But actually, manufacturers design them to do that. It's for a tiny burst of peak speed. The key word here, and it's so important, is sustained. A brief spike is okay. A processor that's living at 95 degrees for 10 minutes straight? That is not okay. All right, enough theory. We get it. So how do we actually see these numbers on our own machines? It's time to build out our arsenal. Let's look at the best tools for checking our CPU's vitals, no matter what operating system you're on. Okay, quick pro tip. When you open one of these monitoring tools for the first time, you're going to see a ton of sensor readings. It's a lot. It can be super overwhelming. But here's the secret. You really only need to watch one. Just ignore all the others and find the sensor labeled CPU package. Sometimes it's called CPU die. That's the one. That's the main number that tells you the overall temperature of the entire processor. For all you Windows users out there, you are absolutely spoiled for choice. HWINFO is kind of the gold standard if you want to see every little detail. If you just want a simple number that sits in your taskbar, Core Temp is perfect. For a slick, gamer-friendly dashboard, NZXT Cam is fantastic. And of course, for the real enthusiasts, the official tools from AMD and Intel will give you the most accurate data for their chips. Now, if you're on Linux, you've got a couple of great options. For anyone who lives in the command line, LM Sensors is an incredibly powerful and simple package. But if you'd rather see a nice visual graph, pSensor is awesome. It basically takes all that same data and puts it into a really easy-to-read interface, a lot like the Windows tools.
And for the macOS crowd, things work a little differently because of how Apple locks down its hardware. You really need dedicated apps to get this info. iStat Menus is the best of the best, a truly premium, comprehensive tool. But an absolutely essential free tool is Mac's Fan Control. It not only shows you the temps, it lets you control the fans yourself, which if you have a MacBook is pretty much a must-have. Okay, so you've downloaded the tools, you've fired up a game, and yep, the temperatures are too high. First off, don't panic. This is fixable. It's time for action. Here is a super clear 5-step plan to fight back and take back that performance you've been losing.
So we've laid out the whole plan right here, from the easiest fix to the more involved ones. Step 1, and honestly the fix for probably 80% of people, is just cleaning out the dust. It is the #1 enemy of cool PCs. Step 2 is a quick airflow check to make sure your fans are all working together, not against each other. Step 3 is jumping into your BIOS and setting a more aggressive fan curve, which basically tells your fans to spin up sooner. If you're still running hot, Step 4 is replacing that old, crusty thermal paste. This can make a huge difference on a PC that's a few years old. And finally, for all the laptop users, a good cooling pad can seriously help.
Now, let's just take a step back and think about this whole process a little differently. We've been talking about this like we're fixing a problem, right? But I want you to reframe that in your head. This isn't just a repair. This is an upgrade.
And this is the most important takeaway. By optimizing your cooling, you aren't adding any new power to your machine. You are simply unlocking the full potential that you already paid for when you bought it, all that performance that was being suffocated by our invisible thief, thermal throttling.
So, if you only take away 3 things today, please make it these. First, know your safe zones. Keep it under 55 degrees at idle and under 85 when you're pushing it. Second, always watch that one-key sensor, CPU package. And third, never forget that your real enemy is thermal throttling, this silent performance killer. And that all leads us to this final thought. You don't always need to go out and buy a new processor or more RAM to get a faster PC. Optimizing your cooling is, without a doubt, the smartest and by far the cheapest performance upgrade you can possibly make. We've really covered all the essentials today, but believe me, this topic can go even deeper. For the complete written guide, for direct download links to every tool we talked about, and for some more advanced tips and tricks, make sure you visit the full article over at en.techfocus.rs. Thanks so much for watching.